Hello, everyone. This is Emily. I am going to re-record lecture 2, 2.2, I'll say, from September 7th, 2018. The reason why I'm re-recording it is because Zoom did not record the original lecture, so I'm going to hopefully do an abbreviated version of the lecture last week. So just as a recap for the agenda of the lecture, we are going to go through file setup and map setup to hopefully get you set up for the next assignment, assignment 2.2, which is going to look at the RDU forest, which is a project that Chilen's research class, which a few of you are in, are going to investigate this complete semester. So let's get started. This lecture PDF of the agenda can also be found on the Google Drive. I'm going to close my email here. Okay, and this PDF is important because it has some hyperlinks to a few websites that I mentioned in the first class that host some data that we're going to be uploading to our map. So to get started, hopefully by now everyone has ArcGIS Pro loaded on their machine and has an ArcGIS online account that is working. So let's open ArcGIS Pro. Okay, so you will see here, hopefully Pro has opened, you'll see your account. If you've logged on before, it should default back to your NC State account. If not, sign on. You may get a window, an Esri window that asks for your logon information, and go ahead and do that. Whenever you start ArcGIS Pro, you always get this window that either has links, recent links to work you've worked on, or you can create a new project here on the right. So for the purposes of today's lecture, please select the blank template. What you'll see here is when you select the blank template, you can name the project and then also the location of where the project is going to be stored. ArcGIS Pro has a new function where it stores all of your files for the projects that you're working on into one neat package. For those that are familiar with Adobe InDesign, the way that it links to other documents and then packages them together in a nice folder, it's very similar to that. So for this class, what I'd like for you to do is to get used to filing your project files in the same folder every time. So if you are able to go to Google Drive in our class folder, you'll see that I've set up a folder setup folder that you should download and store on hopefully the hard drive that you've purchased for this class. So you'll see when you open this folder, I've created these subfolders, and you're welcome to create more, but these are the critical ones that I hope that everyone will have. So you'll have assignments, data, lectures, map projects, and references. In the data folder, this is where any data that you download online or you create, I'm hoping that you store your data in this folder. You'll see that in all of these folders that GIS is going to directly connect to, instead of using spaces, we have underscores. GIS does not like spaces and file names, so get into the habit of either using no spaces or using an underscore or a hyphen. So within the data folder, you'll see that I've created a template. I personally like to store all the data geographically so that if I'm working in multiple projects and a similar location, I can go to that folder easily to find the data. I'm suggesting that you organize things by state and city. And so you'll see here, this is just the naming convention that I'm suggesting that you do. So hopefully you have this stored on your hard drive, this folder template. And then in addition to that, I'm hopeful that you not only have this template, but download the data folder from Google Drive, which is already preloaded with some Raleigh data that we're going to use for this lecture. You'll see here, I went ahead and added the county. So starting with the state, county, then city, and the file name, but you can do it however, whatever floats your boat here. So within the data that I've downloaded for you, just to get started, if you open it up, I have these subfolders for you that you can copy and paste for all of your other data folders. You'll see buildings, which is self-explanatory, cadastral, which is mostly property and parcel type data, climate, cultural, demographic, elevation, and if you just open elevation really quick, you'll see that there's a folder for contours. So this is going to be vector data like polylines, 2-foot contours, which is mostly what we're going to be using in the first half of the semester. And then the other folder is called DEM, which stands for Digital Elevation Model. And these are raster images of 3D information, which we'll get into more depth later on in the semester when we talk about LiDAR data and different raster-based elevation information. We'll also have geologic information, habitat, hydrology, imagery, which mostly are aerial photographs, infrastructure such as utilities, land cover type, which is different ways to categorize the land, whether it be impervious surfaces or agricultural areas, anything like that. Other, which are just things that don't fall into these categories, obviously. Parks, recreation, open space, political boundaries, transportation, roads, bus lines, bus stops, and then vegetation. So hopefully you have downloaded that to your external hard drive. And then once you do that, we can follow along with this lecture. So back to ArcGIS Pro, you'll see we're creating a new project. I'm going to call this lecture 2-2. And I'm going to navigate to where you should also navigate to, which is your external hard drive with that folder template. So if you click the folder with the arrow, you can browse to that location. So mine is on my D drive. And then hopefully you've labeled this class name or something easy to find. And then you just click on, for this, we're going to keep all our map and projects in this folder. So all you have to do is just highlight it. It's located here, and then hit OK. And this is where it'll store all of your information for this lecture and moving forward on this map. So you hit OK. And now it's creating a project file. Speaking of project files, what's new to ArcGIS Pro, again, these project files which store all your data in these neat packages. The type of file that is called a .aptx file. So if you see those in your folders, that is the sort of native file for which those projects live. Okay, so when you open ArcGIS Pro first, hopefully it looks something like this, and it might be very familiar to you. It looks many of the ribbon panels look a lot now like Microsoft products like Office or Word, any of those products. And then you have a ribbon panel that's very similar now to CAD and Revit and other programs. So that's one big change in the new ArcGIS Pro. So you'll see here you have a couple of different ribbons. At the very top, you have where you can create a new project or open, much like File in Microsoft Word. And then you have Project, Home, Insert, Analysis, View, Imagery, Share. Then here you'll have a Contents panel, and all of these windows are movable. They can float or they can attach. The Contents panel is a really important panel. This is where all your layers, all your data will show up that's in your map. And right now we're looking at ArcGIS Catalog, which is much like just Windows, a folder Windows like this, where you can see, you know, a folder with all of the other subfolders or information in it. Let me find one that actually has something in it. So for instance, you can see all the folders and the files in them. Arc Catalog is very similar. It's just specific to ArcGIS, and it reads the specific ArcGIS files. So now you see here new map, which is what I'd like for you to click right now. So this is going to be just a basic map that we're going to start for the RDU forest. If you click this little arrow pointing down, you'll see you have other options in creating a new map, a new global scene, which is a very large, large-scale sort of map that covers a large area, or a local scene, which is a smaller map of a much smaller area, and then base map. We'll talk about base maps and these other types of maps later on, but for right now, we want to stick to new map. You'll see here that new map is located under the Insert tab if you're not there already. For some reason, when I opened my ArcGIS Pro, it defaulted to Insert. So let's select new map. And you'll see here, aside from catalog, we now have a map ribbon up at the top. So catalog, again, is just a window that shows all your file information that GIS is linking to, and then map is the map itself. We'll get into other types of information that can be stored up here later, which have to do with importing or maps that you may export for use as a PDF or something like that. We'll get to that at the end of the lecture. So you'll see here now that we're in map that the ribbon has defaulted to map. These are what they call contextual ribbons. So depending on what you're doing, these ribbons will change based on what ArcGIS is anticipating you'll need up at the top. You'll also see here that a base map has sort of defaulted to loading of the United States. And that map is actually shown here in the Contents panel. And you can check or uncheck it to show its visibility. Again, this is the Contents panel. For any data that you add, will populate here. You can organize how you see the layers or the data depending on these different icons. So you can group it just by the drawing order, so what's on top versus what's behind. You can group it by data source, group it by selection, editing, snapping. There's just a lot of different ways that you can manipulate that content panel, but for the most part, you want to stick with this list by drawing order. So before we add any data, there's a couple important sort of file housekeeping items that I want to alert you to. So if we go back to the ribbon that says project, you'll see that it's much like Microsoft. It takes you to this sort of overall file properties window. This is important for a lot of different reasons, and you'll get more sophisticated with how you tweak these options later on in the semester, but I just want to show you a few things that are really important. So if you go to, let's just go to licensing here for a quick second, you'll see here you should have a license through NC State until June of 2019, and that's an advanced license, which is nice. And then it also shows you the extensions that you may or may not have. It's looking like we don't have any extensions licensed right now. But one important thing that I learned the hard way of not to check is this authorize ArcGIS Pro to work offline. In theory, this would be a really great option to have if you don't have internet access and you want to check out a license and use GIS without a connection to the internet. However, they're still working out, I believe, some quirks with this and that. I checked this last week, and then it still thinks I have a license open, even though I don't. So I would advise you not to check this. So that's the only thing I wanted to show you here. But additionally, if you go to options, this is where you can see sort of your current project information. And starting here with units, you'll see here that it's defaulting to feet, which is nice. But if you wanted to use meters or survey feet or kilometers, you can change that here. You can also change your angular units or area units, square feet versus square mile, and so on. But for now, we just want to default to feet and degrees for angular units, and then square feet for area units. Another fun thing about GIS that you might want to get into later on is that it can track and document every process that you go through. So it'll, whatever buttons you click, it will record that for you. So you can enable that here. It's going to be kind of a hefty file, a large file. So we may not get into this in the first half of the semester, but if it's something that you want to play around with, you can do that here. Also, an application, you'll see general, and we'll get into geodatabases in the next lecture, but just know this is where you can navigate to where basically your data or the maps that you create are stored. And I think that's all that we're really gonna go through there. There are other customizable features like the color of your selection tool and things like that. And then there's some sort of really custom CAD things that we'll get into later. So for now, I just wanted to make sure if you go back to current settings that you're happy with the name of your project. Again, Lecture 2.2. This is the location of where this is stored. You can see that APRX file extension here. Your home folder should be your hard drive, map projects, lecture, and your default geodatabase, which is just another way to talk about folders for GIS, which we'll get into later, where those are stored. And so all of that should hopefully be all in the same place. So you can just hit OK. That's really all we need to look at here. Just wanted to point out a few of those items. So let's go back to the map. So if you just hit the back button you'll hopefully see a base map of the United States. So we're really just going to go along all of these ribbons and talk about what they do very quickly. And in the next lecture, I will give you a handout that summarizes what we've done to date and with definitions of terms, and then what tools we've gone through. So if you want to go back and explore those a little bit more, you forgot what we did, you'll have those in the agenda and in the terminology list. Okay, so you can see here we have this base map. One thing that is, there's some quick sort of shortcuts to going to where your data is stored, so you don't have to always go through your computer registry to get to one folder where all your data lives. You can create shortcuts to those. So I want to show you how to do that real quick through Art Catalog. And you'll see here there's Art Catalog ribbon here, and there's one here over to the right. I'm going to go to the one that's on the ribbon at the top. So if you just go back to there, you'll see we have maps, toolboxes, which we'll talk about later in the next lecture. A little bit today at the end of this lecture, databases, styles, folders, locators. So to create that shortcut to where your data is, which for today's lecture is going to be that North Carolina, Wake County, Raleigh folder that you downloaded from Google Drive. If you'll go up here, again, to this contextual ribbon that is hopefully on the Insert tab, and go to Add Folder. What you want to do is navigate to your external hard drive where the data is that you downloaded from Google Drive. So mine's on my D folder, D drive. Then you want to click here to your lecture folder, data, and then you're going to add, just click, highlight North Carolina, Wake, Raleigh, and then hit OK. So now when you go to add data, it will automatically take you to that folder every time. Just helps sort of skip some steps. So if you go back to map, we're going to want to add data. So if you, again, hopefully you're on the map tab, scroll over to add data. And in GIS, anytime you hover over any of the tools, you'll see this box that gives a description of what that tool is. So for add data, you see it says add data to the map. So before you click the big icon with the plus sign, please click the arrow pointing down first. And you can see that you can add data to the map from your folder, from a Windows folder. You can add data from a path. You can add XY point data, and you're not going to know what all these mean yet, but know that there are different ways to add data. Let's go ahead and just add data to the map, the first one. And hopefully, if you did the last step correctly, it will take you to your North Carolina, Wake County folder. Mine actually defaulted to the last folder that I went in. So if not, you can go the long way to get your data, external hard drive, class folder, data, Wake County. And let's go to the political folder, and let's add the Wake County line. So this is a shapefile. This is a polygon of Wake County boundary. So just hit select it and hit OK. So you'll see here that it zoomed right to the extent of that data. You can see Durham over here, and that it's blue. And if you toggle this on and off, it will go on and off. So every all data, shape files, raster files that are GIS files have information loaded in them, and that is called attribute data. So the beauty of GIS is that it not only draws shapes or represents spatial shapes, but it also has loads of data that's associated with that shape. So one way to view that data in what we call an attribute table is to right-click the data and go to attribute table. In GIS, usually you can right-click anything in the contents panel or anywhere else and have a quick sort of menu of options of different tools that are associated with that data or that file type. So let's click attribute table. So you'll see here, just move my zoom thing up here. You'll see here that this window pops up and it defaults to sort of being anchored to the bottom of your page. Typically, I like to use 2 monitors so I can move my attribute table and that kind of information to one monitor and just have my map on another. You can unanchor it from the bottom of your page by just selecting the Wake County line tab and moving it. So this makes it free floating tab, free floating window, or you can anchor it to the right, or you can just have it free floating. I prefer to have things free floating. So you can see here, because it's only one county boundary, it's only going to have one attribute. There's nothing more to show than just the county data itself. So that's really not that fascinating, and it doesn't really have any information really stored with it, like the geometry or the area of the polygon, excuse me. So that's not a good one to look at, but you can see that it's there. So I would just close that. And now let's add the other data that is in the political boundary folder, which is going to be the townships. So we're going to go to add data. Hopefully it takes you back to where you just were. Go back 1 to political, and let's go to townships. Township shapefile, add it here. So you can see here that, let me just clear something here for you, that it is only really showing one color for all of Wake County. So let's look at the attribute table. Right click, attribute table. And you can see here that there's every township in Wake County. It looks like there's 19 townships in Wake County, or 20, I'm sorry, 20 here. You can see 1 of 20 selected. I'm going to again move this up so that it's free floating. And you can see here, you can make it the size of the screen. We can make it smaller. So I'm going to move it down a little bit. You can also just drag it down here. Okay. So you see here, when you select Wake Forest, for instance, it highlights a boundary of Wake Forest Township, but you don't really see the line associated with that. That's just because it's the symbology of townships is only showing all of Wake County. So we're going to change that and play a little bit with the graphics of the information that we have. So right here, for some reason, it defaults to catalog on that right-hand window, but we want to navigate to Symbology. So you can see here that it says Symbology Townships, and it's a single symbol, meaning it's just one symbol for all the data that's in there. But we want to have different symbology or different representation for all the townships. So if you just drop this window down, you can see that you have some options for how you represent the data. So you have single symbols, which is showing now, unique values, which will give unique color representation to all of the 20 townships. You can do graduated colors, graduated symbols, unclassed colors, and proportional symbols and dot density. And these sort of symbolize things by quantity, which is interesting. Like if you have population and you want to, if you have a population column in your attribute table that talks about how many people live in each of the townships, and you want to have different colors that represent different densities, or you want different dots that are to the scale of the different densities of the townships or things of that nature. But for now, since we have a pretty simple data set here that just has the township name, we want to do unique values. You can see here, because I have Wake Forest highlighted, it's also highlighted here. It's selected. And the selection buttons are all located here. So to clear that, we can just hit clear. And you can see that the selection goes away. Up here, you have your navigate tools. And I want to navigate back to just so I can see all of Wake County. So what you can do is just go to the extent of your data. So one way to do that is you could just go back to where you were before and kind of go sort of record the extent of your data. Another way to do to see just the extent of certain data is, again, if you right-click townships, you can go to zoom to layer, and then it will fit that data neatly into the window. Otherwise, you can just scroll in and out. This world button goes to the full extent of all the data. So because we have this world map, it will just go to the world. But we want to go back to Wake County, so you can either go previous extent or right-click zoom to layer. And another important thing that you'll always use in any GIS map and that you should get used to using is creating bookmarks. So bookmarks are just those extents recorded so you can easily, quickly go to them. So for this one, I'm going to just create, now that we're zoomed to the extent of Wake County, I'm going to create a new bookmark called Wake County. So even if I zoom to the whole world and I want to quickly go back to Wake County, I can either use that bookmark, or again, I can right-click, zoom to layer. All right, let's go back to Symbology. So now we are in the Symbology of the townships, and we have this primary Symbology that is under the category unique value. So what we want to do is that for each field, so here you select a column in the township attribute table. Let's just go to township, name. And so for each different name township, it's going to have a different color, and it will default to a color scheme, which this is a little Easter eggy. And GIS doesn't have the best graphic capabilities, and so later in the semester I'll teach you how to use Illustrator to make GIS look a little bit more sophisticated, but nonetheless you can see that it defaults to a color scheme. You can change that sort of random color scheme to how it populates each township. There's not many here, but you can see if you just click on this one, it will randomly change those. And so that is a quick way to do that. However, there's also ways that you can customize them. So what I did there is on Bartons Creek Township, I just double clicked the symbol here, and you can see, oops, Don't double click, just click it once. You can see here, I'm going to make this window a little bigger here. You can see here that it has some default symbols that you could use. You know, you can change it to that symbol for whatever that is: government, park, water, or there's some custom 3D symbols there. Or so you're in the gallery mode here of what those standard GIS symbols are, or you can go to properties and do a very custom change of what you want that color to be. And you could do this for each of the townships. So here you can see color. You click this button that's the arrow that's facing down, and you see all these different color swatches. You can change it that way. So if you hit apply, you can see that it changes to that green. Going back, you can get even more fancy with your own sort of recipes for colors, whether it be RGB or HSV or CMYK. Here you can also adjust the transparency if you want to be able to see things below it. So for instance, I'm going to change that to 50%, hit apply. And if you zoom in, that's not really great. Let's change this. You can't really see the base map below. Let's go back, maybe change it to, oops, wrong way. 75, hit apply. Oh, and you know what's going on? You can't really see, and it's turning blue. And that's because townships is above the Wake County. And so if we were to click that off, there you go. Now you can see the base map below. All right, so I'm going to change this back. You can also use the slider if you want. To 0% transparency, hit apply. You can also change the outline color of the shape. It defaults to black usually. You can also just say no color. I don't want outline. But if you do want to outline, you can also change the width of it. And what we'll do in the next class is that these widths can be scale dependent, depending on what scale you're drawing at. So you can imagine if you're really far away, you might want a different line type than if you're really close in. So we'll get into that later in the semester, but just know that you can adjust those here and that it can be scale dependent. We'll get into that with this enable scale-based sizing. Okay, and so those are just sort of basic appearances that you can play with on each of the township features. And then if you go here, there's some other properties that we can actually customize and add different effects. But for the sake of this introductory lecture, let's just stick to the symbol colors and go from there. So I'm going to change this back. I don't know if that's what it was before. I guess we'll just leave it there. It's fine. So you can just close out of that. And okay. You can just close out of that if you like. And then to get back to Symbology, there's multiple ways to get to the same tools. So if you were to go back and you close that window like I did, you can go to Map, Appearance, Symbology, and then that'll populate up again. So we'll go through these again, but just know there's multiple ways to get to these windows, whether it be right-clicking, using the ribbons, or using the preloaded contextually driven windows to the right. All right, Let's see here. All right, so attribute table, changing symbols. Let's just keep going along the toolbar at the top to get familiar with all the items that are up here. Again, this Wake Forest is selected, so you're just going to hit clear. We'll get back there in a second. So we talked about bookmarks. Let's go to zoom to Wake County. Go to XY data. This is where you can actually enter in latitude and longitude coordinates, but we're not gonna, it's not really something that I do use a lot of, but you can see here you can type them in manually and go, but it's really not something that I do a lot. Okay, now getting back to layer, we talked about adding data. But we can also add GIS's preloaded base maps. So right now we have the topographic base map that shows, it shows cities, townships. Looks like, you have roads, maybe even some wetland, low-lying areas, creeks, and some other labels of neighborhoods and counties. But there's other base maps that are out there. One that you'll probably use a lot is imagery. So if you you just click the arrow that's pointing down on base map and go to imagery, you'll see here that only one base map from Esri can be shown in your contents tab at one time. I'm not really sure why, but it is what it is. And just for the sake of this, I'm going to minimize this a little bit and close the attribute table so you can see the full screen. And then I'm going to unselect the go to XY data. But you can see here you have a pretty decent aerial imagery. Depending on where you are in the world, it can be pretty high quality. If you want a higher quality than what they're showing, typically you want to go to a GIS data source, which I'll show you here in a second, to see if you can get higher quality imagery. And I believe I have already downloaded that imagery for you for RDU Forest, but we'll look at that here in a second. So that's one base map. You can see it sort of changes color or changes what it's showing dependent on the scale. So they have, they're automatically going between different image types based on how close or how far away you are. I'm going to turn off the townships here just for a second. What I am going to do is I'm going to modify the wake line just so we can see it over the imagery, just for reference. So I'm going to make it have no fill color and have a white outline color. I'm going to make it 1 point, hit apply. Actually, I'm going to make it make it hot pink so you can see it. So you can see where we are in the world there. The other thing that you want to get into the habit of, just like in any program like CAD or any of your Adobe projects, is hitting save every once in a while, which is Control S as a shortcut, just so if something crashes, you don't lose any of the work that you've done before. All right, so you'll see here we have Wake County and imagery loaded. Other base maps include things like just simple canvases, light gray canvas, with just really simple data. Or more sort of complex, sort of open, more transportation based. But typically, imagery is something that you're going to use a lot of, so it's good to have it loaded in there and have it at the bottom of your page. So everything else is on top. So we looked at base maps. We talked about adding data. But let's talk about where we get data and some other ways to not only to download data, but to connect to it through API websites. So Within the lecture PDF that is on Google Drive, there are some hyperlinks there that I already have loaded. And the ones that we're going to go to are Raleigh Open Data and Wake County Open Data. So I'm going to go to Raleigh Open Data first. So either you can go to the hyperlink in that lecture PDF, or you can just Google really quickly Raleigh Open Data GIS or something similar, and it should bring you to this page, which is integrated with ArcGIS, which is nice. You can even log in with your Arc Online account if you like. It sort of keeps track of the data that you downloaded and notifies you when data is done downloading. But this is really nice, easy way to find GIS. However, note we're a little spoiled here. Not every municipality in the country has such well-organized and easily accessible data as we do here in Raleigh and Wake County. So in Open Data Raleigh, there's multiple ways that you can search for data. You can just, search things like elevation or whatever you might be looking for, and anything related to elevation will pop up. Or I'm just going to go back here. You can search by category if you just want to browse the different data types that they have. And then the GIS group with the City of Raleigh has done a lot of fun Google Maps and different publicly available ways to look at different types of data about the city, whether it be sort of development that's going on, or crime, or property sort of tax information. You can sort of explore those there, but for our purposes, we're going to stick to the data. So if you go to something like Parks and Rec, you'll see here that you have greenway trails, open space, Parks in Wake County, and Raleigh Parks. And I believe I downloaded all of this in the data folder. But what is important to note is that usually to get a whole picture of open space and parks, which is a data type that we use a lot of, you have to go between not only municipal level data, Raleigh Parks, for instance, but you may also need to download Wake County parks, because their data sets might not necessarily be coordinated. And then beyond that, you may need to look at things like the state park system, their data. So you'd have to go to North Carolina Parks and Rec and find their data and download that to make sure things like Olmsted would show up in your map, which hopefully they are showing up in one of these, either the Wake County or the Raleigh Parks. And then federal data you might need to download for national parks. So just know that the data is usually organized by the agency that oversees that, and that you might have to go to multiple agencies to find their data to get the full picture of something like open space and parks. The other great new thing about how Esri has created these open data platforms, municipalities, is that you don't necessarily need to download the data every time if you want to load it into your map. So let's click on Raleigh Parks, for instance. So you'll see here, it's very well organized. It has a description of what the parks are, the attributes that are going to be loaded with that data. So you can see here, it's going to have park type and that. You can also scroll down here, it'll show you all the attribute columns, like an Excel spreadsheet, and that attribute table. So this data is going to have the address of the park, the development status, a file number, the acreage, the name, the ID that the city uses, how big it is, zip code, and there's one more, but all these other things that you might not always necessarily know what each column stands for, but usually in the description or in the metadata, which is data about data. So it's a description of all the data, how they got the data, what the data means. you can sort of look up and try to figure out what some of these acronyms might mean. So in open data, you can see here it has the last time that it was updated, how much data is. There's 201 rows, so I guess there's 201 parks in their data set. And if you want to go ahead and click on View Metadata, which you can also view in GIS once you have the data loaded, but they go ahead and give you a link to that. You can see here they have some descriptive information, a description of what it is, why they created the data, disclaimers about its use, just to cover your butt information, who created the data, and then who to contact if you need more information or you see errors. It's really important with the metadata is to understand when it was last updated. And you always want to make sure that you have the most recent data. And if you're going constantly to these open data platforms, hopefully you can assume that all the data that's on there is in fact the most recent. So when you go to the data here that's stored on open data, you also have an option to either download, and what you want to do is download, you have these options. You can download just the spreadsheet, which is basically the attribute table, so no geometry associated with it, just the attribute information. You can download a KML file. So a KML file is, I don't remember what it stands for, but it's a file that you can easily upload into Google Earth. So if you didn't have GIS or you had a client that couldn't afford Azure products and you wanted to give them some data, you could either download the KML version of the shapefile, or in GIS there is a tool that translates shapefiles to KML or KMZ so that you can easily load them into Google Earth. Shapefile is typically what you want to download for use in your ArcGIS map. And then you can also just download the whole file geodatabase, which has all of this information in it, packaged in a folder, which, if you did this for all the data you ever use, you might need 5 terabit hard drive. So to save space, unless you really want that information, I suggest just downloading the shapefile. The other way that you can load the data, which again is new, what I alluded to earlier, is this API tab. So you'll see here that it gives you these web links. So if you just either right-click copy or hit Control-C for copy and go back to ArcGIS Map and go to Add Data, you can add data from a path. And so that path, you would just Control-V or right-click, paste that database, the link to that data on Raleigh's website, and hit Add. Now this is useful if you just quickly want to see the data. However, if it's very intensive data like property data or elevation data like for the whole county, you certainly don't want to rely on doing it this way because it will bog down your machine and it'll be hard to link, and you're really sort of dependent on the speed of your internet connection. So I would default to downloading data instead of connecting to the APIs, but I do want to just show this as a quick way to connect the data. So I'm going to turn on the world imagery, and you can see here all of the park data is loaded. So you're wondering, what is this park? What is this shape right here? Once you download it, you can use this Explore tool, which is an important tool that you always want to default, probably the tool you'll use the most, but it's usually defaulted to when you're in GIS to select information, and then you get this pop-up of the attribute of that shape. So you can see here, this is Durant Nature Preserve. You can see here, it's a park type, it's a nature preserve, it's developed, here's the address, and they acquired it in 1979. And then you can see here the area, which if you can remember from earlier on, this should be, it's probably in square feet, and that the length is in feet. So I'm going to close that pop-up, and let's go back to the City of Raleigh open data. I'm going to go, let's see if we can figure out what this LWCF is. I'm going to go back to view metadata, and it may not be in here, so it may be a dead end, but I wanted to see if they had a description of that, and I am not seeing it. So that was, in fact, a dead end. Let me see if it's described here. No, it doesn't. Okay, we can dig into that later. Sometimes you have to reach out to the city itself to get that type of information. So that's Raleigh open data. There's a million ways that you can search within this website, but typically you want to be in the find data, or you want to search or by a name or by a category. So the other website that we'll be using a lot to find data is Wake County open data, and there's a lot of similarities in the data that's in Wake County, as you can imagine, and the Raleigh open data. But if you either you can connect to this on, again, the PDF from this lecture, or you can just search Wake County GIS. And the reason why I want you to search Wake County GIS and not Wake County open data is because I want you to see older data versus newer data and how it's stored, because more than likely the older way that data is hosted on Wake County is what you might see if you're going to counties that aren't as sophisticated in their GIS, don't have the same resources as Raleigh, is more like some of our rural counties out there. So if you get a Wake County GIS and just scroll down to and go to Maps and Data, and then go to Download Data. You'll see that they have a link here to their open data that looks a lot like the Raleigh open data, but then they also have the old way. This used to be the only data that they had available in the way that you got it. So this is sort of the old school way of hosting data, which just links to their FTP site directly. Now I went ahead and downloaded the topo data for you for RDU Forest, but I want to show you the steps that you have to take to figure out what to download for a specific area when you're on these older types of websites. So you'll see here they have property, transportation, major streams, floodplains, open space, all the same stuff that you would see in the city of Raleigh. But let's go to the Raleigh ETJ data for topography. So we want this topo data, which is a shapefile. Now, if you click on that link, you'll see that it takes you to this FTP site with all of this data, which are 2-foot contours for all of the city of Raleigh. So how in the world do you know which to download? So these represent tiles. So they've broken up the city of Raleigh into a grid. Each grid square has a label associated with it, and this is where you then go to find that tile and download it. And what you'll find probably with any project you ever work on, unless it's really small, a small project, is that you're always going to need more than one tile because you'll find your project boundary overlaps 2 tiles, not just one. But if you're lucky enough to just have one, then that seems to be more unusual than common. But anyway, let's go back to download data to figure out which tiles we need to download for the RDU forest. See here that there's a link. It's called PDF Grid Map available for download. So if you click on that, you'll get a grid of actually all of Wake County, not just Raleigh. So what you'll want to do is zoom in to your project location. So hopefully you know where your project is. So if we were looking for RDU Forest or looking for the airport, we want to go up near Morrisville, and then, oh, we see Aviation Parkway. We see Lake Crabtree. So we're probably going to want to grab, I like to grab a little bit more than you might need. So these are probably the 6 or 9 tiles that you're going to want to grab. Particularly when we're doing hydrological modeling or analysis, you want to get the ridge lines outside of the boundary of your project so you can figure out all the water that's coming to your site. But just to be safe, just get a little bit more than probably what you need. So I would get 0757, 67, 77, 5666, 76, 5565, and 75, and download those. I've already downloaded those for you. You don't need to do it right now, but I wanted to show you that those are the steps that you would need to go through to find that type of data. Now, let's, I should also point out that sometimes municipalities have CAD data for you to download, not just the shape files in GIS, but I will show you how to convert everything in GIS to CAD. We'll do that in the next lecture. But maybe if we go to, well, let me just see, no, it says shape files. You can see here the format. Let me just go to major roads real quick. I think it's actually going to download a zip file. If it opens, you'll see here that a lot of these typical data types, they go ahead and give you the shape files. So when you open this and GIS catalog, again, the Windows version of reading GIS files, you won't see these 4 files. You'll only see the shape file, but all of these file types support a shape file. So they all go together, and you need all of those to read all the information on the shape file. So actually, it's going to include this and this as well. But then you have this CAD, these nice CAD files that you could load into CAD to create a basement. So that's nice that some municipalities do that, but if they don't, I'll show you how to convert them. But let's go ahead and go to Open Data for Wake County. It's very similar to Raleigh. You'll see the same, it looks very similar. The colors are just slightly different. And you'll see things that are at the scale of the county level. I'm not going to go through all of those, but just know that those are 2 really important places to get data, particularly when we're working outside of the city of Raleigh. Okay, let's go back to our map. Okay, back to our map. Right now, I want to get you prepared to complete assignment 2.2, which is creating 3 maps for the public meeting that you're going to be having in make-believe with the public about the RDU Forest. And so you can read that assignment brief on the Google Drive folder. But I want to get you prepared for that for the second half of this lecture. So what we want to do is figure out where our project site is before we move further with showing you some of the tools and data types. So I'm gonna, if you go back to the folder, let me actually see, so you can see what I can see what you see in Google Drive. Let me move the Zoom window down. If you go to assignments, assignment 2, 2.2, you'll see there's the design brief for the RDU of forest. And then you'll see here the client has given us a map outline of the study area, which is basically all of the property that RDU currently owns, which is adjacent to the Olmsted Park, 540 and 40 and US 70. So let's navigate to that approximate area. And so let's add a base map that has a little bit more information than just the aerial, so we can find our way. Let's go back to that topographic one. And this may not work for some of you. I know in class people are having some issues with this, but if you go to the map folder and go to locate, I believe this is the right one, and you type in Raleigh Durham Airport, oh, there, and it'll pop up Raleigh Durham International. It will take you to that area. So you can see here, there's 540, there's 70, and there's 40. And so I would just zoom out a little bit, and let's just go ahead and make a bookmark of RDU. So create bookmark, create name, and hit OK. I'm going to close the locate tab. Okay, so this is our project area. You can see here that we're just at the edge of Wake County, showing up there at the top. Another important thing that we'll talk a lot more in depth in the next class are coordinate systems and projections. So as Alini taught you in the first lecture, all data has sort of a calculation of how it is displayed on the Earth's curvature. And so there's a lot of different coordinate systems and projections that use different math to do that calculation about how things fall on the curvature of the Earth. The more local the coordinate system, the more accurate it's going to be. So North Carolina has its own projection system that's very specific to the curvature of the Earth as it lies in the state of North Carolina. So it's very detailed because it's only focused on North Carolina. However, if you were to use a coordinate system that's for the entire world, it's going to be less accurate for very sort of smaller scale zoomed in locations. So the data that you have that you download from the city of Raleigh, from Wake County, from wherever, from NASA, whoever you're downloading the data from, they've defined a projection for the data. And then when you load it into GIS, GIS uses that calculation to display the data. So usually the first data that you add to your map is the projection that the map sort of runs with for as you're using the map continuously. And so how do you find out what projection your map is? How do you find out what projection your data is? What if you want to change it? We'll talk about changing projections in the next class, but what I want to show you now is how to know what your map projection is and what your data is. So let's start with the world topographic map, which is the base map that we're using, which again, if we zoom, let's go to zoom to layer, it's showing the entire world. So it's going to be less accurate for something at the scale of the city of Raleigh, but it's a geographic coordinate system that works for the entire world. Let's go back to a bookmark of Wake County. So if you right-click that and you go to Properties, so right-click the World Topographic Map, which is your base map that shows the world, go to Properties. You can see here it has the name of the layer. You can change whether or not you see this layer depending on the scale of your map, and I'll talk about scale here in a second. But what I want you to go to is the source so you can see where that data is linking from. So this is linking to a server from Esri, actually, these base maps, they created them, and it's actually in meters. But it's able to convert because it knows your data from the city of Raleigh and feet. It does the conversion for you, so everything's sort of lining up. But if you go to spatial reference, just click on that, you'll see that the projected coordinate system is WGS 1984, and then it gets into the actual projection name, and then the unit that it's in. So just hit OK, so you know that. This gets into you know, angular units, a lot of sort of geometry of that calculation that I can't describe, like what inverse flattening is, but it is quite interesting, but beyond really the scope of what you need to know for our purposes. So just hit OK there. And now if you go to your map layer, so if you close that, that's the map that you're showing right now with all the layers data that you have loaded, and you right click that and go to properties and go to coordinate system. You'll see that it has defaulted to the WGS 1984 because the world topographic map was the first layer that you added. So again, it defaults to that first layer, and which is a geographic coordinate system, WGS 1984. But you can see here, it also has what the other data are in there, but we're gonna go to those individually. So just hit OK, and let's go to parks. So if we right click parks, go to properties, you can see the source. This was actually one of those that we connected through the open data. So it'll have the website URL there. And then if you scroll down, go to spatial reference, you'll see that it's NAD 1983 State Plain, North Carolina, which is our special North Carolina coordinate system. So let's hit OK. Now let's go to the Wake County line, properties, spatial extent. You'll see here the shapefile data source is actually hopefully your hard drive. If for some reason you've unlinked to that shapefile or something's happened, you can, or you want to change where it looks for that data, you can change that here, the path to where that data is. Just as a note, but getting back to the coordinate system, you can see here actually Wake County has it as GCS WGS 1984, which is interesting. And let's see what township is too. Right click properties, spatial extent, it is the WGS 1984. So I typically like to use the local coordinate systems on my maps, and it's usually best practice to set these up, you know, as you're creating your map in the beginning, but you can do it after the fact as well. So let's go back to map, right-click, properties, and you can see here it has the different layers, coordinate systems loaded and defaulting to the WGS. Let's click the 1983 State Plain. And while you're doing that, you see this little star. Why don't you go ahead and click Add to Favorites, because you're going to use that one a lot. So it should have added to favorites. If not, you can right click and add to favorites, and then hit OK. You may not have noticed it, but the shape of the larger map has changed slightly, the world topographic map, just so you can believe me. Go ahead and zoom full extent. Okay, you see how now the shape of the Earth is sort of a, kind of looks like the Wu-Tang symbol. Let's go back to the map, right-click, properties, and go back to, let's go to layers, to that WGS, and hit OK. And now it looks like just a flat map of the world. So you can see that's representing the different calculations of those coordinate systems. But let's go back to our state plane coordinate system and hit OK. And then let's go to Bookmarks, Wake County. Or no, let's go to RDU. Okay, so let's hit save because we changed the map coordinate system. This isn't critical that you do this. Just know that you can look and see which coordinate system your map is using. It will make the calculation what they call on-the-fly projection, so you don't have to always modify any of the projections so that they can translate and talk to each other. Sometimes you do, and we'll talk about that in the next class, but know that on-the-fly projection happens. But if you happen to add data and it's off in Africa or in outer space, then there's something wrong with the projections. They're not talking to each other, and then you'll need to reproject some of the data to the coordinate system of your map. But we'll do that in the next lecture. Okay, so let's get prepared for assignment 2.2. So you'll see here we have Raleigh within our Raleigh-Durham International Airport within our window of view. And what's important to also show down here in this window at the bottom left, this is the scale of your drawing. So this is 1 to 64,983. And that is going to be actually in inches, which is kind of a weird scale. So to get feet, you need to divide by 12. But what you can do for us in landscape architecture and planning, usually we do at this scale, we like to know about things in feet or miles. So if you click this arrow pointing down in the scale window and go to customize and go to scale format, you can select 1 inch equals feet, hit OK. And now you can see when you zoom in, 1 inch equals 238 feet. You can also enter in your own, or go here and select 1 inch equals 2,000 or something like that. So if you are going to be using typical scales, you could create, let's go 1 to 2,000, create a bookmark for each of your scale. So I'm going to do RDU, 2,000 scale for later on when we're going to make a map to export. Okay, so I showed you this Explorer tool is really important. If you click the arrow pointing down, it's really just a select tool in some ways and gives you the attribute pop-up. But you can see, if you click the arrow pointing down, when you click on data, it will either select the topmost layer or all the visible layers, the selectable layer. But usually you just want to default to the topmost layer. These are a little bit more advanced and not as heavily used. So let's look. We have our parks data loaded. Let's see what parks are around RDU. So let's see here. What is this? So we're going to click it with the Explore tool, and we see that's Mount Herman. It's an undeveloped park. It's the address. And it has a file number that's associated with it. Let's click this one over here. This is Lake Lynn, developed. It was established in 1987, and it's about 2.2 million square feet. Then down here, Brookhaven neighborhood. And so you can see I would be interested to know how far this Leesville Park is from maybe the middle of RDU. So one thing that you can do is add, use this measure tool. And again, if you click on the thing pointing down, you can measure the distance, an area, or a feature, but we're going to measure the distance. So as the crow flies, which is a straight line from, let's just say, the middle of RDU to this park here, you can see loaded, it's about 20,000 feet. Just hit it. Just hit erase to stop measuring. And you can do multiple lines, and then you can copy your results and paste it into a Word document, or you can just clear the results. You can also measure square footage or acres, so you can do a shape and measure things that way, and then hit delete. Okay, so we have that. So the Explore button is kind of nice because it has these sort of pop-up. It used to be an I, just the letter I, to give you information about data, but now it's called the Explore tool. You can also just, you know, use the same Explore tool to pan around and zoom in and out. Another way to select data and get more information about it is the Select tool here. So you can see the selection toolbar. You can select by just clicking. You can select by dragging. You can hold Control and select to unselect that one, but keep these two selected. This is really a nice tool because it is connected to the attribute table and what features are selected. So if we right-click the parks and, data and go to attribute table, move my zoom window here. You can see down here it says 2 of 201 features are selected. So we have, let me go back to map, explore, zoom out here. We have these 2 features selected, right? We selected those, 2 of 2 selected. Just gonna go back to the select tool. And so this shows you all the records in the parks attribute table, but if you select this icon to the right, it shows only the ones that are selected. So you can see Lake Lynn and Strickland Park are selected. This is just really useful when you're looking at various data types and just trying to understand, you know, spatially where they are, how they're related. And what's also cool about the attribute table, it is much like an Excel spreadsheet where it has all these rows and columns, but you can also do calculations really quickly. So you can see here for the selected features, there's a shape area, and if you just select that column and right click, you could sort this column, sorting with ascending, so the smallest is on the top. You can sort descending, so the largest is on the top. And then you can also run statistics. They call statistics. So you can see here, it's giving you the mean, the average of that area. You could do median of those 2 numbers and run some other data there. I'm going to close that. You could also do it for all of the data. So you can, of all the parks, so you could sort ascending, so have the smallest park on the top here. So the smallest park is DuPont Circle, and you're wondering where the heck is that? So if you select that feature, right click, you can actually zoom to that, and maybe zoom out a little bit. So DuPont Circle, oops, just explore. Looks like it is just, it's near my office actually, which is here in the Boylan Heights neighborhood. And then let's see who is the largest, Lake Wheeler. Let's go to that. Whoa, there's Lake Wheeler. You can see the acreage, 873 acres. It was established in 1956. You can do the same as looking for the oldest park. Let's sort descending. Looks like there's a lot of null data there, but 1887, what park is that? Pullen Park. Zoom 2. And you can see here that. So a lot of cool things that you can do with these attribute tables. Again, much like an Excel spreadsheet, you can select multiple features using the select tool. So let's go back, for instance, to Bookmarks, RDU, zoom out and just try to select, I don't know, all the parks that are here. There's 10 parks nearby, and this is what kind of parks they are. They're developed, and they sort of range in size and when they were acquired. And then they range in type too. You have special park, community park, neighborhood park. So that's all interesting. So to clear your selection, you just hit clear. Another feature that you can use in the select area of the ribbon is selecting by attributes. So for the parks, go here and show all the parks. Sort of taking its sweet time here. Oh, not sure what's going on. Okay. So here's where you can sort of type in a recipe for selecting parks. So the data that you want to select are parks. You want to do a new selection. So if you already had something selected and you wanted to add to your selection, you could add to or remove, but we're going to do a new selection. And this is where you are going to add sort of a recipe or SQL or an operator for what type of attribute you want to select. So if you add a clause and we say, let's select all part types that are equal to Greenway and hit add. And then if you wanted to add a clause and also select and parks that are greenways and let's see, were acquired. There's the acquisition acquired certain time period, which this might be a dead end. You could do that, or maybe even better yet, all greenways that are in the zip code. Let's do 27605. Add that and see if any of parks match that those attributes, both greenways and within the zip code. So you hit the run tool. You can see that it's running and it's searching, it's searching, it's searching. It says it's completed successfully. And lo and behold, there are no parks. There are no greenways in the zip code. All right, well, let's change it. Let's try a different zip code. Let's do 27608. Update that and run it again. Well, it looks like we've hit a dead end there. So let's go all of the data here. Get a park type. I probably should have looked into this before I did the demo, but let's go to Greenway, Walnut Creek Wetland, 27610. Go backwards here, hit update, run. And then, of course, we get the one feature that we were looking for. Actually, yeah, 27610. Let's do 601 so that you can see that there's multiple ones. There we go, update. I'm going to deselect that, hit clear, and then run it. Okay, and now here you can see there are two features, Patterson Green and John Winters Greenway in 27601, and then we can zoom to those, see where they are, and there they are. Okay. Okay, for the assignment, assignment 2.2, we need to show the extent of the RDU parcel and show it in relationship to the open space and park system around it within a buffer of it, and also any other attributes that we might want to show within the parcel that are related to conservation or use for commercial or other types of development. So the first thing that we need to do is create a boundary for our study area, which is the RDU forest. Now there's many different ways that you can create that boundary. I'm going to go ahead and just zoom to our RDU bookmark. So we know approximately it's in this area, but there's other ways that we can define the boundary. We could, one, manually draw the boundary ourselves based on information that we might have from another map or from a client. But the easiest way to do it with the information that is easily accessible to us is using the parcel data from the city of Raleigh. So I have actually downloaded that data for you, and it's a large data set. So we have to be careful with these large data sets. They can really bog down the machine. And we'll talk about, leaving that layer off so it doesn't bog down your computer too much when you're scrolling in and out. But first, let's add it. So go to Add Data and navigate to your Raleigh folder. Go to Cadastral, which is, again, property data, property boundaries, etc. Go to Parcels, and let's load that parcel data. I already have one loaded. I'm going to delete one of these. And then I'm going to take the fill out. So I'm going to click on the symbol, alter the symbology. I'm going to no fill. I'm going to have a pink outline. I'm going to make it 1 point and hit apply. You can see just how long it takes every parcel in Wake County to load. And so it is quite a bit of data. But just for a second, we want to see it all, because we want to see how they define the owner of RDU International Airport, and then we can use that ownership data to hopefully isolate the parcel boundary. So if we open up the parcel attribute table, you'll see that there's a bit of information. There's the number, the PIN number, which is sort of like the tax ID, identification number that you can use to look up real estate values and whatnot from the city's website. You have a calculated area, which is, I believe, going to be in acres. And then you have an owner, and you have addresses for those owners, the deed book, the deed page, the date that the deed was created, and then you do have some deed acres, building value, land value, total value, billing, property description. heated area, square footage, street names, all kinds of great information here. But for our purposes, we're really trying to find all the land that RDU owns in this general vicinity. So if we use the Explore tool and just click on the RDU, and on the Explore, we're just selecting the topmost layer. We can see that the owner is Raleigh Durham International. So we might want to search all property or parcel data that has that owner. So there's a couple of different ways that we can do it. We could sort the owner column by ascending and then scroll down to the R's. But with 366,000 records, that might take us a while. So maybe a smarter way to do it is to select by attributes. So let's use our Select by Attributes tool. So we're going to select parcels. We're going to create a new selection, and we're going to create an expression where we're going to add a clause that says that the field owner is equal to, and we're going to type it Raleigh Durham International. Hopefully you spell it right, International. And if there weren't so many records, it might auto-populate and go ahead and populate it for you. But because there's so many, it might just take too long. So we're just going to hopefully make sure that we spell everything right and hit Add and Run. And it did not select anything. So let's try this again. Let's edit the clause. And let's type, it might be case sensitive, Raleigh Durham. Now, Airport Authority is interesting, but that's not the one that we want. Raleigh Durham, oops, International. Let's update that. Let's try to run that again. Okay, so it was case sensitive, and we see you have one selected feature, and that is really the parcel that we want. If you go back to our map from Chilen, that is in the Google Drive, that does look about right. So that's what we need. Now, what we want is we want this to be its own isolated layer, because what we want to do next is create a buffer around it, because we want to understand how many different parks are within a 10-mile buffer. But if we buffered the entire parcel data layer, it would do all of Wake County. So we don't want that. We want to just isolate this one layer. So there's a real quick and dirty way to do that, and that's what I'm going to show you today. But later in the semester, I'll show you a couple of different ways to do this, but this is the quick and dirty way. So we have this parcel selected. You can see here, it's Raleigh Durham International is the owner. It's the extent that we want, so that's good. So if we right-click parcels, which is what we have the data selected in, and go to Data, we're going to go Data, Export Features. There's also another way that we can do this. We can go to Selection, and then Make Layer from Selected Features. You can do it either way. This actually makes a temporary layer that then has to be exported again. But for the sake of a temporary map, if you don't need that layer later on, this will suffice. But let's go ahead and do Data, Export Feature to go ahead and cut to the chase and create a new shapefile. So the input feature is going to be parcel. You can browse if you wanted to have an input not in your map. It sort of defaults to what's already in your map. But that is indeed what we want. We'll talk about environments in the next class, or later probably when we get more into the geoprocessing. But now we want to define this layer, and this is going to be called RDU. I've already done this once, so but I'm going to do it again. Just call it RDU, and it'll overwrite what I already have. Oh, it may not. So I'm just going to do RDU2. It may not want to overwrite it, so that's fine. And then we're going to hit run. And hopefully it will add a layer. So if we turn off parcels, a layer that is called RDU. It's only the RDU parcel. Let's do Control S, hit save, or you can also go up here to project. And I just hit save, otherwise it wouldn't be grayed out. Hit save. So we have a nice layer. So now we want to create a 10-mile buffer off this parcel. So now we have a really nice outline, which will be great for the maps that we're exporting of what the boundary or study area is. But now we want to do a buffer. So one tab that I haven't showed you yet is the analysis tab. And this is really where all the magic happens in GIS. This is where all the geoprocessing and the spatial analysis occurs. Luckily, today you don't have to be a computer programmer to run scripts, but all the scripts now are neatly bundled in what they call these toolboxes. So if you click the tool, you can see on your right-hand side in the geoprocessing window, there's hundreds, if not thousands, of tools that you can use to do all kinds of different things. So I'm going to gently and easily sort of step you into that world of geoprocessing by just showing you a few tools here and there, and then in a couple more lectures we'll really get into the detail of what the capability of these tools are. But for now, we want to just dip our toes into a few tools. So the one that we're really going to do today is the buffer tool. So you can see here you have your favorites, which are going to be the tools that you've recently used, which for most of you is not going to be any of the tools. And then you have all the tools. And if you know where the tools, if you know the name of the tools, so the navigating through these and trying to look for them based on how their categories, you can simply just search for them. So if you type in buffer, you'll see that buffer is an analysis tool, but you can just click on it. And what we're going to do is we're going to buffer RDU, the RDU parcel, which is mine is going to be called RDU2 because I couldn't overwrite my first one. I'm going to name it, put it in my lecture 2.2 geodatabase, and I'm going to call it RDU underscore buffer 10 mile, and I've already created one before, so I'm going to do two. But get in the habit of creating a naming convention for yourself. I like to use the name of the original data, the tool that I used, or an abbreviation of the tool that I used, and then the distance or the characteristic that I used to run the tools, which here is going to be 10 miles. So I'm going to hit save. I'm going to edit two so I can do it because it is whatever one I already have. Then we're going to, for distance, we're going to enter in 10. And for the unit, we're going to do miles. Now these other inputs, you can see here, if you hover over them, an eye will pop up and it'll define what that means, give you a little bit more information, and it'll let you know if it's required or optional. So obviously the input feature is required. The output feature, the name that you want to name it, is required. The distance is required. But then you have these optional features that we'll get into later that you can just let default to what they already are. So we're going to hit run. And you'll see in your contents bar, an RDU buffer layer has been added to your map. It just looks like a sea of blue right now, but if we right click and zoom to that layer, you can see that there's a 10-mile buffer. Just to double check, we can go to map, measure length, and go to the edge. The edge, it should be about 10 miles. So we have our 10-mile buffer. You'll notice that that 10-mile buffer goes outside of Wake County, which poses an interesting task for you for your assignment, but I won't get into that right now. But what I will do is let's now see all the parks that intersect this 10-mile buffer from the RDU property. So if you remember, we could easily do that a couple different ways, but one is the select by location that we talked about earlier. So we select by location. We want to select parks, and then here, what's the relationship of the parks and the buffer? Well, we want to select parks that are within, or not completely within, but just overlap. There's a couple of different ways to define that, but let's say within that 10-mile buffer. Again, these other are optional. Search distance, so you could do another sort of buffer, or you could add to a selection, create a new selection. We want to create a new selection. So let's run that parameter. So now you see all of the parks that are within a 10-mile buffer selected in your attribute table for parks. So there's about 155. That's quite a bit. So if you want to sort of have this information as a table or do anything different with it, you could export this information. There's a couple of different ways that you can do it. One easy way is just to copy and paste. So if you see the selection bar up here at the top, over to the right, there's a copy selection. If you hit that, it's going to copy your selected rows to your clipboard on your computer, and then you could open a file like an Excel file or a Word file, and just go over to it and hit Control V or right click and paste, and then you have all the parks that are in a 10-mile buffer in Wake County from the RDU there, which is very nice because then you can also see what types of parks they are. And then if you know how to use Excel or a similar format, you can sort of sort these as you'd like. So I'm going to hit save again. So now we have all the parks within a 10-mile buffer. Now I'd like to create another layer, its own layer of these parks to separate them from just all the parks in Raleigh as their own thing. So much like the RDU property, we're going to right-click parks and go to data. We're going to export this feature. It defaults to exporting the features that are selected. So we're going to export parks that are selected, and we're going to call this parks RDU 10 miles. Hit save. Again, I like to name the file first by the original file that it came from, and then the parameters that were used to select it. Hit save. Hit run. Okay, and now we have all parks within 10 miles. We can even just, if we wanted to change the symbology of the buffer, do the outline color. Change this to a different color. Let's stay with the pink theme. And not long on that. Take the space map off. So now we can see all the parks within 10 miles of RDU. So now what we want to do is make a map. And that's one thing that we haven't shown yet. But before we do that, another thing that will be useful for you when creating maps is knowing how to label things. So luckily, you don't have to manually label anything in GIS. It's something that it can auto-populate as long as you have an attribute with the label name that you want it to be. So what we might want to do for this map is label all of the parks that we have within the 10-mile buffer. So to label these features, you can right-click that feature and go to Label, which is about halfway down. And you can see here that it labels them. You actually have some duplicate names. They're kind of big at this scale, but we'll have to look at the map to see what works. So let's just leave it labeled for now, and then let's jump to creating a map of this 10-mile buffer and all the parks within them. So let's go to Insert. So if you remember way back at the beginning of this recording, we inserted a new map, which gave us this map tab here. But now we want to create a map to print with a title and a graphic legend or a graphic scale bar and a legend and your name and whatever other information that you want to put in there. So that is going to be called a layout. So that's new layout. So if you right click the arrow pointing down, you can choose the page type, the size of the paper that you want your layout to be. This map is for a public meeting, so people will be drawing on it. So you probably want a pretty big map. So let's do 24 by 36, which is architectural D. And so it's creating a new layout. I'm also going to just quickly go back to map and just deselect, clear that selection and get rid of this attribute table. All right, we go back to layout. You can see here that you have basically a blank sheet of paper. So what we want to do is we want to add the map frame from this map that we've created over here. So in Insert, you'll see map frame. And what's great about this is that you can just do a blank one, or you can do one that's already set to one of your bookmarks. So let's go to the RDU 2000 scale if you have one. And you can see here that you have some stuff selected here. And I'm going to move this over because we want to leave some room for a label of the map, a title of the map, our legend, and some other information. So I'm going to move it maybe just a hair over there. But you can see it doesn't quite fit in the boundary that we want. So let's go to right-click RDU layer, and let's go to zoom to layer. And then you can see that the RDU, let me turn this off real quick. The RDU fits nicely in that screen, and let's hit save. Okay, so for this map, this first map that we want to do, we want to show all of the parks within a 10-mile radius of RDU. So if we just zoom to that layer of the property boundary, that's not going to work. But let's zoom to the extent of that 10-mile buffer. Okay, now we can see everything with all of our parks. Now, if you go to view, whoops, sorry. If you go to in your layout, if you go to 1-to-1 here in the navigate, this shows you how big it actually is printed. So that's helpful when you're trying to just see how big the text should be for the actual size of your window. I'm sorry, of your sheet that you're going to be printing out. So this is useful too to see what the size of your labels might be. So I just turned off the labels, but let's turn them back on and get them to a good legible size. So let's go to Parks RDU 10 mile, label. You can see here that the labels are not exactly, they're pretty close, but we have some duplicates. So to alter our labels, play around with their placement and their size, we want to look up at the top here and go to Feature Layer Labeling. And you can see here that there's a few things going on at the top where we can change the font, we can change the size. There's this. So for instance, we can change these to maybe be 8-point font, or they have some preset ones. It takes a while for it to change. No, let's go back. Let's go 8-point, look pretty good. Let's just go to something, oops. Go back to layout, 1-to-1, back to labeling. Let's go to a simpler font. Something real simple. Okay, you can change the color. And you can also change here what is being labeled. So it defaults usually, if there's something called name, it'll default to name, but you could name it by park type, or you could create, with this little tool here, you could do name and park type and hit apply. Oops. Name. Oops. So you could add more attributes to the label, which might make it a little long and not be desirable. But if you change the language to VB script, we'll talk more about what that means later in the semester, you can create an expression with plus signs and other operators to add the name, and then you could just put the plus sign and the park type, and then hit apply. You can see here it uses the name and the community, the park type adds it to the label, but that's way too long, so we're going to get rid of that. Delete it. Hit apply. Change this to a little bit smaller and hit save. The other thing that we can do with the label tools is change how or where the label is. So you saw up here, these are sort of the quick tools that you can use, but they're also more in-depth tools similar to these, but just more characteristics in this window where you can do things like change the font and size, of course, but you can do underlines, strike throughs, halos, all kinds of different color types on that. You can do all uppercase, you can do normal case, hit apply, see how that changes. So you can see there, position, you can offset it, you can rotate it, you can create a halo, you can create a shadow, and you can make it sort of like a call out, like a balloon. You see the balloon here is white, so it's overlapping the actual data, so that's not really a great thing. So we're just going to do none, keep it simple. Always default to keeping it simple. And then position, placement. You see here where we have Leesville overlapping. And then right now it's sort of in the middle of the polygon, which is good for us, I think. We want just regular placement. You could also, if it were a river or some sort of strange typical data type, it could maybe align the label to the line of the river. But here we want it horizontal inside the polygon where it can, but there are other options. It can curve with the polygon. Place you can, if you don't want the label to go outside of the polygon, you could say you don't want that. You could have offsets. There's all kinds of, you could change the orientation. You could have it straight or curved. There's all kinds of options that you can do here. But we're just going to sort of leave it here. Avoid holes in the polygon. So that's this option and position. There's also here, see if I can hover over if it defines the fitting strategy or conflict resolution. So since we have these overlapping Leesville or we have duplication, that's considered a conflict resolution. So we may want to remove duplicate labels. Right now it's selected as do not remove, but let's remove all duplicates. And you can see here it has removed Leesville. And the reason why there's a duplicate there is because you see this tiny, tiny little parcel. So Leesville Park is in 2 parcels. That's why it is labeling both of them, but GIS is smart enough to understand that these are really close together and duplicates, so it removes them. So we're gonna go back to our map, just a quick overview of labeling. I'm gonna close that window out, and we're gonna go back to the layout tab, and we're gonna zoom to the actual page width so we can see everything. So you can see here, look at all these labels. You might even want to make them a little bit smaller, but on our tiny screen, it looks legible, but it actually could be legible. And again, this is a very simple map. You would definitely want to add more information to this map for your assignment. But I'm just using this as an example to how to use these tools. So one thing that we talked about in the lecture is what every map should have printed. And so hopefully all of you already know this, but we're going to go walk through how you add items to your map. So every map should have one. Luckily, they're here in a nice row for you. A north arrow. You can see here, and I'm just going to drag this and make it big so that it's legible for you. So it's sort of defaulted to this one. I'm going to hit delete. But if you drop down the arrow pointing down, you have a whole bunch of different areas you can choose from. There's more. Again, I think simpler is always better. So we'll just use a simple north arrow here. And it's kind of tiny initially, and we don't want it to be too big. So we'll make it kind of small. Just push and pull scale. We also want a scale bar. So you can see here, move my zoom window, that the scale is 1 to 6484. It's kind of a weird scale. We may want to just customize this to like a more whole number, maybe just do 7,000 feet if you'd like. And so you can just type that in right there. But let's add a scale bar so that you can scale off of it. So again, you click down, you can add alternating bar, whatever you like, and put that here. And then if we zoom, now this just zooms to your page, zooms to selected elements, or you can use a magnifying glass, but it doesn't zoom within your map, it just zooms on the page. You can see here it's in miles. I think miles is okay because we wanted it to show the 10 miles. But if we wanted to show feet for some reason or make it smaller, you can drag and drop. So you have your 10 mile there. But you can also right click and go to properties and change the units to feet if you desire. And then you can see it changes to feet. But for this scale, I think miles is good. So we can go back and just zoom the full extent of the page. Going back to insert, we'll also like a legend. So once you click legend, you can just draw a box and it will populate with all of the layers that you have here. Go back here. I'm going to zoom to that. Whoops. You can also just scroll with your mouse. You see it's labeled exactly how it's listed here. So if you'd like to change the legend, there's a couple different ways that you can change it. You can see here, you can lock it or make it non-visible. You can synchronize with the map with all the attributes that it already has. You can show a title, so it says legend or not. You could change the name of it. So we're going to do show legend. There's some word wrapping and spacing that you can alter there. You can put a background color to it or an outline. And then you can mess with the position there, or you can just drag and move it around. And then in the text symbol, obviously you can just change the text type. There you go, and play around with that. You can rotate the text. Again, a lot of different formatting, word spacing, customization that you can do. Don't get too fancy. Ben's laughing at me. And then if you don't like the way that these layers are labeled, you can alter them a couple of different ways. I'm going to just show the properties here real quick. You can alter them here, or you can alter them in the map itself. So right here, you could type parks, oops, within 10 miles, oops, RDU, and then it'll change it here. RDU 10 mile buffer, RDU You just click one in there, RDU study area, and then Wake County boundary. Okay. Then zoom and extent. You can move this around to wherever you want, make it smaller, larger. Usually the defaults are pretty good size, but again, you can use that one-to-one view just to see how big it is at the paper scale. Go back to insert, and you're going to want a title. It's an important thing. So I don't know why it defaults to this tiny thing, but you can say RDU park map, whatever you want to call it. Text symbol. You can change it here. Make it large. Or you can drag it. And then, of course, you'll want to enter in other information, perhaps, like your name. The date is always important. I think that's good. And anything else that you might want to add. You can also do shapes, lines, pictures, charts, all kinds of other things. You can even do other map frames to create key maps. But for the purposes of this, this is really all you need. So once you have the map how you like it, you can export this map. So to export, you go back to layout. Oh, before I do that, you can, if you want to change anything, you can here. You can change it to portrait, reshape everything. Just go back to landscape. But to export your map, you want to go to share, and this is where you can upload it to your team through the internet, through ArcGIS Online, but usually you're going to either print or export it. More than likely, most of you are going to be exporting the PDF and then printing. That's what I suggest. So let's go to Share, Export Layout. You can select file type. So you can see here you have PDF, TIFF, other images, image types. Let's do PDF. We're going to do a resolution. You always want to do at least 150. You can see with the export options, there are different ways that you can export, but the default options are good for now. You're going to want to name it, and you're probably going to want to put it in your assignment folder. And name it RDU Parks with your name or however you want to label it. Hit export. And then voila, you have a map. Sometimes it takes a while. To open. And there it is. This is not a lovely map, but it does have the information. So there it is. And then you'll want to email me your maps for the assignment. So that's all I have for today. Don't forget to hit save. But know that you can create multiple layouts. So to do the map 2, you can go to insert another layout, new layout, Part D, creating a map frame, similar to what you had before. And then now you'll probably want to do a map that's closer to your study area. Zoom to layer, and then go from there. So I hope that was helpful. I'll try to edit these video documents so that they're organized by topic, so you can skip to different parts of the video based on what you need help with, and then go from there. Okay, I will see you guys on Friday.